There are a number of advantages to using higher strength fasteners. Firstly, it offers the ability to downsize fastener diameters, so not only reducing the size and weight of the fasteners themselves, but also allowing you to downsize the complete assembly or piece of equipment. You could benefit from an increase in material strength and capacity, providing an additional margin of safety and security. Bumax achieves the strength increase through cold working the material. As the material is stretched and deformed, it builds up internal stresses in the material by rearranging the grain structure. Manufacturing processes that deform the material include wire drawing to reduce the diameter, cold heading to form the fastener itself, and finally thread rolling to press the threads into the material. All this is vital steps in building the strength of the material. Tensile testing is conducted on every batch manufactured at Bumax. It helps to determine the yield strength and tensile strength of the fasteners. Full-size bolts are placed into an adapter in a hydraulic test rig. The fastener is subjected to an increasing load, which stretches the fastener. The fastener reaches the yield point of the material. This is the point at which a load that is applied will stretch the material. Once the load is released, the material will revert back to its original size. The load below yield point is known as the elastic range, very much like a rubber band. However, when the fastener is loaded beyond yield, any stretch of the material will be permanent and will not return to its original length. This is known as plastic deformation. As you continue to load the fastener, the material will stretch plastically right up to the point at which a fracture will occur or failure. This is known as the tensile strength. This is the stress-strain curve and explains the previous slide in a graphical context. Stress is the applied load, which is equal to the stress in the material. The strain is the deformation that occurs in the material. RP 0.2 is the yield point, and RM is the failure point. Necking is the plastic deformation described in the previous slide. Uniform elongation is the elastic deformation, and linear. This slide shows how the stress-strain curve develops during testing and how the results are presented. Ductility is the material's ability to undergo plastic deformation before fracture. Think of steel as similar to plasticine. Ductility is a measure of how stretchy the material is. Ductility is important because this gives bolts a margin of safety before they fail. If a bolt is overloaded, then there will be an indication of the bolt permanently stretching. This gives time to resolve the issue during partial failure before the bolt becomes dangerous and breaks. One of the advantages of Bumax fasteners is how much more ductile they are compared to other generic stainless steel fasteners on the market today. Fatigue occurs when a material is subjected to repeated loading and unloading, otherwise known as cyclic loading. Repeated stress may be more demanding, even though less than the yield strength. Microscopic cracks can form at areas of stress concentration such as surface defects, inclusions, slag. Bumax fasteners are excellent due to their very high material quality and mechanical properties from strain hardening. Tightening torque, preload, and friction have an important relationship. Together they determine how well a bolted joint connection will stay together. When applying a tightening torque, only a small proportion of this torque will go into stressing the bolt. Around 80 to 90% of this torque will go into overcoming the friction due to the roughness of the surface. Friction under the bolt head or nut, and also friction in the threads. With many fasteners, the friction coefficient, or how rough the surface is, can vary a lot. So when you tighten the bolt, you can get a lot of variation, which means that the actual bolt preload could be very different even though you are applying the same torque level. This is very important as you could risk too low preload, which can lead to loosening, or you could end up with too high preload and risk overstressing the bolt. Bumax bolts benefit from a very consistent level of friction at 0.14. This gives designers some reassurance that the applied installation torque during installation will result in reliable joint clamp forces. Also, because of the consistency of Bumax bolts, this can be a big advantage in serial production premium products, where it is important to maintain the same parameters and product quality and reliability needs to be maintained. The two graphs below show the advantage between Bumax 88 bolts and standard A480 bolts, the importance of ensuring a low and consistent friction in the bolts when it comes to the installation and reliability of the assembly. Galling is a phenomenon common in stainless steel materials. When two stainless steel surfaces are forced together and slide against each other, the chromium oxide layer breaks down and roughness of the surface tend to act like plasticine, essentially tearing against each other. This is what happens when torquing up standard stainless steel fasteners. The pressure between the thread surfaces on installation can cause galling and seizing. Galling also prevents tightening torque from translating into bolt preload. Bumax fasteners are a low risk of galling for several reasons. Firstly, the quality of our material ensures less impurities in the steel. The rolled threads offer a much better surface finish and higher hardness. The consistency of the threads mean a better tolerance and fit. Finally, Bumax bolts come pre-waxed. This is a specific wax that is applied during production. It leaves a thin, dry film that is designed to keep friction low and consistent during installation and helps prevent the risk of galling. Many customers in critical industry sectors choose Bumax purely due to its anti-galling performance. All Bumax products are fully traceable down to the individual box label, with reference numbers for both material and production. Bumax are also available to offer individual traceability marking on fasteners. Every Bumax product manufactured can be supplied with a 3.1 product test certificate according to ISO standard 3506-1. Test data is held on all Bumax production and retained for a minimum of 15 years. 3.2 third-party witness certification can be provided upon request. We are also able to offer additional customer-specific testing. Bumax 3.1 certificates contain the following information: a unique certificate number, material reference number and chemical composition, mechanical test data including tensile strength, yield strength and elongation on fracture, as well as dimensional confirmation. Bumax 3.1 certificates can be all cross-referenced to the Bumax box label.